Hello, people who study mechanics. We're going to do question 5 out of this series, and in this case we also have 3 forces, but the nature of this question is different to the last one we did. So we've got 3 forces, and they're P, Q, and R, so I mustn't use R for my final resultant this time round, and they act on a particle. And the particle is sitting on the origin somewhere here. That's the origin, and those 3 forces are going to act on this particle. And it says find the resultant of the 3 forces in terms of I and j, the unit vectors along OX and OY. So this is OX and this is your OY. Then I would be a unit vector there, and j would be a unit vector there, as we normally use them. So it says find the resultant in terms of I and j. So they give us P, Q, and R, and they are given by 2I plus 5j is P. Q they give us is 2I minus 5j, and R is equal to 3I. So they ask us for the resultant in terms of i's and j's, and the great thing about when they give it to us in i's and j's is this: we don't have to do anything over here with any trigonometry or anything like that. We can just literally go, we're going to add the 3 vectors and we're going to get a resultant. So that's literally my final resultant, which I'm going to call resultant star. Is going to be equal to the vector of that's going to be equal to my vector P plus vector Q plus vector R. And so that means 2I plus 5j, which is P, plus 2I minus 5j, which is R, plus 3I, which is, sorry, that was Q, that's Q, and the 3I, that's R. So literally we just do the i's with the i's and the j's with the j's. 2I plus 2I is 4I, plus 3I is 7I, and 5j plus minus 5j, that's 0j. So we are done. In other words, if you add these 3 vectors, you end up with 7I as your resultant, which means a vector resultant which goes along here with size of 7 is the resultant force for P plus Q plus R. And let's see if it makes sense, just to check the geometry of the question. If P is 2I plus 5j, that means 2I plus 5j, something like this. That's 5 and that's 2. Then we add to that Q, which is 2I minus 5j. So 2I would be another 2I, like that. That would be 2. And then minus 5j, so that's going to get us down here, straight to the same line where we were before, to that line here. And then we go and we add 3I, so that's already 2I, and another 2I, and then we suddenly add 3 more I here. So that makes sense, that 2 plus 3 for 7I. So we could have done that even just by drawing a diagram without doing the i's and the j's. But so you see that this is much easier than the ones we've been doing before. So that's one of the uses of representing vectors as i's and j's, that you can add the components really easily, as you just saw. That was super short compared to the other ones we've done before, where we had to add the components. Now we can well, in the next part it says, for each part of the previous question, which we should have done quite a few of these, but we've only done one as an example. For each part, then find the magnitude of the resultant force and the angle it makes with OX. So this is easy, right? The magnitude of the resultant force, if this had been some combination of i's and j's, then we would have had some i's and some j's, and we need to get this guy here r double star or whatever you want to call it, and we want to find the result, and then we've got the i's and the j's, and we can find the angle. But here it's really easy. We don't even have to do that, because 7i, so the magnitude of 7i is literally 7. That's the magnitude. So the magnitude of r star magnitude, that's a vector, is equal to 7, and the angle to the OX, well, if it's like that and we're measuring the angle with respect to this, then the angle is 0. It's perfectly along there. So 7 and 0. And since it was in newtons, we've got to add this here, because the question is written in terms of forces. So hopefully that makes sense, and we'll now go on to the another exercise in the book with some different types of forces, and that will be relevant to next week's work. Alright, so hopefully you've found those useful. See you in lessons tomorrow.